So we're going to solve a few exponential equations to give you some more examples, and we're going to talk about how we can look at the equation and determine if we can use our shortcut method or the longer method. So the first thing we do when an equation says solve, because it doesn't always say solve the exponential equation, sometimes it just says solve, is we want to know what type of equation we are dealing with. And in this case, we go, okay, well, where's my variable? What's going on? And my variables are in the exponent. So that's how I know it's an exponential equation. And then I might ask myself, well, do the bases relate? Or do they not relate? And in this case, they do relate, because you know that we have our powers of 3. 3 to the 0 is 1. 3 to the first, 3. 3 squared is 9. 3 cubed is 27. So we've talked about these special powers, and we want to recognize when we see that in a problem. So I see 3, 9, and 27. I can rewrite all of these terms as base 3. 27 is 3 cubed. My 3, that's already a 3, so I'll leave that as 3 to the 5x. And my 9 becomes 3 squared. But what we want to pay attention to is that 3 squared is still raised to an x to the 1/2 power. So, x to the 1/2 power times 2, power to a power we multiply. That gives me 3 cubed equals 3 to the 5x times 3 to the 2x squared. Now, on the right side of my equation here, I have two bases multiplied, and when we are multiplying two equations of the same base, we can add those exponents. So I have 3 cubed equals 3 to the 5x plus 2x squared. And so what we notice now is we have one base on the left equal to one base on the right. They are the same base. So I can drop those bases, and my exponent on the left, 3, remains, equals my exponent on the right, 5x plus 2x squared. So I have now gotten rid of the exponential part of the problem, and this is now a quadratic equation. So remember, when we're solving quadratic, and we know it's quadratic because the x squared, we want to get that equation into descending order equal to 0 and attempt to factor it. And most of the problems you're going to see in this section, once it becomes quadratic, it should factor. We know that that doesn't always happen in the real world, but when we're learning these strategies, we try to keep them a little easier. So this is going to become 0 equals 2x squared plus 5x, and that would be minus 3. And if I look at factoring this, I've got 2x and x. I need to figure out where to put my 3 and 1, considering 1 would be negative and 1 would be positive. I need a positive 3 and a negative 1. And we can check that. That's negative x, positive 6x. That's going to add together to give me that. So since this factored, and I have two factors equal to 0, I can now set each factor equal to 0 and solve. 2x minus 1 equals 0. That's going to give me x is positive 1/2, and x plus 3 equal to 0 gives me that x equals negative 3. So I end up with two solutions for my exponential equation that I just solved. And remember, you should always check. Both of these will check in our original function up here. They both check out. Right, so the answer there was 1/2 and negative 3. So let's do another example. So let's solve this exponential equation. Now, the last example we just worked on, we were able to write the left and the right side of our exponential equation as the same base. But if I look at my bases, I've got base 3 and base 2. And I can't write 2 to a power which is equal to 3, or I can neither write 3 to a power equal to something in 2's. So in this case, my bases do not relate. And if the bases do not relate, then we can take the log of both sides. Common log or natural log will both work. We just want to choose the path of least resistance. I don't have an e, so that doesn't mean I should use natural log. I don't have a base 10, so I don't really need to use common log. Personally, I prefer to write ln because it's less strokes. I don't have to lift my pencil as much. So I'm going to take the natural log of both sides. I've got the natural log of 3 to the x equals the natural log of 2 to the x minus 1. Once I've taken the natural log of both sides, we like to use our power rule. And the power rule of logarithms says that if I have a power in my argument, I can pull that in front and write that now as a product. So rewriting this, I have x times the natural log of 3 equals x minus 1 times the natural log of 2. And I left my parentheses out. If I don't have parentheses in here, then I might only multiply that 1 by natural log of 2. But all of that was in the exponent, x minus 1, so that entire expression is in front, and we will need to remember to distribute here. So if you remember back, our rules, we said after we take the log of both sides, we said we're going to use the power rule. Then we can distribute, we may have to collect, factor a GCF, and then divide. All right, and so we talked about those rules in the video which preceded this, but we took the log of both sides. Power rule, distribute, collect, factor, divide. So in order for me to solve this, I'm going to run through those steps. Now, natural log of 2 is multiplied by both of those, so this is where I will distribute. I have x times the natural log of 3 equals x natural log of 2 minus 1 natural log of 2. Of course, I don't need to write that invisible 1 there. It's understood. So at this point now I have x's on both sides of the equation. So I want to collect those x terms both to the same side. So using my additive property for equations, I'm going to subtract x natural log of 2 over to the left side. Once I've subtracted, you'll notice now that both of my x's are on the same side, I can factor a GCF. So if I factor that x out, that leaves me with the natural log of 3 minus the natural log of 2 equals still negative natural log of 2 on the right. So that GCF, factoring that out, that now allows me to divide by ln 3 minus ln 2, which gives me that x equals negative natural log of 2 over natural log of 3 minus natural log of 2. And that is my exact answer here. And if I type that into my calculator, my approximate answer is negative 1.7095, get 11291. I do want to encourage you to make sure you can type that answer in your calculator and get a correct approximation. Two things about this answer. One, because it's a rational exact solution, it would be possible for you to get natural log of 2 divided by natural log of 2 minus natural log of 3, which would be the exact same value, but we've negated both the numerator and the denominator, which keeps it the same sign. Or also, you want to remember that you can't cancel those out. That's not a common factor, right? So this does not simplify any further here. Canceling would be incorrect. Okay, so, again, make sure you can type that in your calculator and get the correct decimal approximation. So let's do one more example and we'll solve one more exponential equation. In this situation, we have e raised to the 4t power equals 200. This says solve. The first question you ask yourself when you read those instructions is solve what? What type of equation am I solving? And it's exponential, okay? So we know it's exponential. And then we have to say, well, do the bases relate? Or do they not relate? And by that I mean, can I write e as a power that gives me 200? Or vice versa, 200 as a power that gives me e. And in this case, this is exponential. Bases do not relate. And since the bases do not relate, we take the log or natural log of both sides. So we can take the log or natural log. And because I have an e, I'm going to definitely lean towards natural log. So the natural log of e to the 4t equals the natural log of 200. And because we understand how to simplify with exponents, the natural log of e, when the base matches the argument, that exponent can come down and we end up with 4t equals the natural log of 200. Solving for t now, I would need to divide by 4 on both sides. Natural log of 200 divided by 4. And that's my exact answer. I do want to show you here that if I had used common log, I would get a different looking exact answer, but they're both going to give me the same decimal approximation. So if I did this and I said log of e to the 4t equals log of 200. I'd use my power rule, 4t log of e equals log of 200. And I would divide by my 4 and my log e, and I would end up with log of 200 over 4 log e. And if I type both of these into my calculator, in both situations, I'm going to end up with natural log of 200 divided by 4. That's going to equal 1.324579342. So that's the answer you should get in your calculator. This is approximate, and this guy is exact. Same with the one in purple there. I just prefer the simpler notation. So there we have it. In this video, we solved 3 different exponential equations.